Hello, Gen Chem students. Over the last couple lectures, we've learned about a handful of smaller gas laws that relate just to variables, and then we brought them all together into the ideal gas law, which linked all four of the variables that describe gases. To review the ideal gas law, you've got PV equals nRT, where P is pressure, V is the volume of the gas, N is the amount, usually given in moles, T is the temperature, and R is the universal gas constant. R's value is going to depend strongly on what the units are for these other four variables. So whenever you use the ideal gas law, just double check and make sure that you're using the correct R value. Well, instead of having to memorize all of those smaller gas laws that I gave you, you can instead derive them as you need them from this ideal gas law. Well, how does that work? The first step is to determine which of the variables change and which do not. You're going to figure that out by looking through the problem text and identifying cues like, what is the final volume? That would tell you volume's changing. Or initial temperature is, which tells you that temperature is going to be changing. You will then rearrange the ideal gas law to put changing variables on one side and non-changing variables on the other side of the equal sign. And it's worth it to note, R will always be with the non-changing variables because it itself is a constant. It doesn't change. Last step is to take the expression of the changing variables and write the new law. Let me show you how this works. Pressure and volume change. We're going to write our ideal gas law down that we're going to start from. And next, we're going to figure out which of the variables are changing and which are not. So we said it was a pressure and a volume change, therefore P and V are changing. And therefore, we're also holding N and T constant. They're not changing. In the equation, we've already got our changing variables isolated from our non-changing or constant variables. So we can move straight to the next step. We can write the ideal gas law to take into account initial conditions as P1V1 equals N1RT1. Then the final conditions expression would be P2V2 equals N2RT2. Now it's important to note, we know that N1R1 or N1RT1 has to equal N2RT2 because N and T are not changing. If we can say that these two expressions are equal to each other, these two, then we can also say that P1V1 has to equal P2V2. And that's the final expression we write down and that we use. So congrats, we've just derived Boyle's law. Let's take a look at one more example. Next, we're going to take a look at an example where pressure and temperature change. So we've got our P and T changing, therefore not changing will be N and V. And you can see they're kind of all mixed up in the ideal gas law as is, so we'll algebraically rearrange it to get our two changing variables on one side. We just divided both sides by T, and to get our non-changing variables on the other, dividing everything by V. Our new expression is P over T equals NR over V. Now remember that the NR over V term is going to be the same under both of our initial and our final conditions. Therefore, the P over T is the one that's going to change, and we can say that P1 over T1 equals P2 over T2. This is otherwise known as Amundsen's law. So now you've seen that we can just rearrange the ideal gas equation in order to derive any of the other smaller laws that we might need to use. I hope that you found this useful, and I wish you the best of luck on your practice final on Wednesday.